Welcome to the Rosenberg International Forum on Water Policy, and this is our third in this series of our virtual webinars. And this one is on groundwater and megacities. And please do feel free to raise your hand if you have questions during the Q&A or post them into chat. And I'm going to pass it off to Soroush Sarushian, the chair of the Rosenberg Forum, to welcome you.
Well, thank you very much, Sherry. Good morning, good afternoon, good evening to all participants. It's my great pleasure as the chair of the Rosenberg Forum to open up our third of this year. I guess this is how our year starts, from maybe September, of the webinars in lieu of the actual meeting that used to take place every 2 years, and the COVID has affected it. So we are excited. It's a great program today, and I don't want to waste too much time. It is my pleasure to introduce Dr. Glenda Humston, who's the Vice President of the UC Agriculture and Natural Resources, who oversees our committees, functions, and many other aspects of environmental sciences at the UC system. Glenda?
Great, thank you very much, Soroush, and welcome to all of our participants on today's webinar. I think this topic on groundwater and megacities is going to be extremely exciting, and we've got some great speakers lined up. I just wanted to make sure folks are aware of why we're doing this. The Rosenberg International Forum on Water Policy was created back in 1996 with an endowment gift from the Bank of America to the University of California to support a policy forum focused on reducing conflict in the management of water resources. Now, as you know, that's a big topic, and over the past years, we've covered many different aspects of that as we have visited different locations throughout the world. And I know I'm looking forward to being in China at some point in the future when we begin traveling again. But it's been a really useful conversation, as I'm sure today's webinar will as well. The endowment was created in honor of then retiring bank chair and chief executive officer, Richard Rosenberg, who had a long time interest in water issues throughout California and was credited with rallying the business community to address many of those water challenges in California. So without further ado, let me hand it back to Soroush, and once again, welcome all of you, and I'm looking forward to the seminar.
Thank you, Glenda. I appreciate that. And the next is, of course, many of the decisions we make about the meeting, the themes and the topics are collectively the work of our advisory board. And I'd like to have each of the members of the advisory board who are present today, if you have other commitments, say a few words about themselves and we can move on. Of course, Christina, go in the order on the slide on the left down.
Perfect. Hello, everyone. Thank you so much for joining. My name is Christina Babbitt. I work with Environmental Defense Fund. I'm based in San Francisco, California, in the United States, and do a lot of work on groundwater. So excited for the conversation today.
Thank you. Lucia?
Well, good morning, good afternoon, and good evening. And so I am Lucia De Stefano. I am associate professor in geology at Complutense University in Madrid, in Spain. And I'm also deputy director of the Water Observatory of the Botín Foundation. So my work mainly on different aspects of water planning and management. And I've been working quite a lot, especially in the past, on groundwater management. So I'm also very excited to be part of this event today.
Thank you, Lucia.
Ariel Dinar. I am a professor at the School of Public Policy at the University of California, Riverside. I am very excited to be here today. The topic is very close to my heart. You know, in addition to water that is close to my heart, groundwater is especially important. And any one of you in the audience who is interested to further develop any connections on questions or ideas related to groundwater, please feel free to write to us. It's not only the webinar, but probably what comes after the webinar that is also very important.
Well said, Ariel. Thank you so much. Professor Duan?
Good evening, good morning, good afternoon, depending on where you are. I'm Qin Duan from Huahai University in Nanjing, China. I'm a hydrologist, of course, surface hydrologist, but I have great interest in groundwater hydrology as well. And also, I hope, we are supposed to have a meeting in China, and I see some of you are in China.
Thank you. Thank you. Alberto will join us half an hour late because he's teaching his class in Madrid. Andrea also will not be with us today. Am I right?
That's correct. And
yeah,
Helen
she had a
come.
commitment. So our two colleagues from Arizona and Dr. Helen Ingram are not available because they have other commitments that they had to attend to. Ben, are you with us?
Ben has not joined yet.
Ben has not joined yet. And definitely my colleague Ayman is with us. Ayman?
Yes, thank you very much, Surush. My name is Ayman Rabi from Palestinian Hydrology Group based in Ramallah. My background is water resources engineering. I've been working with water management since 32 years now, and of course, particularly focus on groundwater. As Ariel said, that is also closer to my heart. I also been an advisory board for the past, I don't know, it's 14, 15 years now. So I think with this kind of very interesting forum, we hope that we can realize and achieve something useful and beneficial for the world. Thank you very much.
Thank you, Ayman. Glenda already introduced Doug.
Yeah, hello everybody. Thanks for being here today. I'm Doug Parker. I'm the director of the California Institute for Water Resources at the University of California, Division of Ag and Natural Resources. And the Rosenberg Forum is our stellar international program that's housed in the institute there. I'm a former professor of agriculture and resource economics, so I've worked in water all my career, and really looking forward to what we're going to hear today about groundwater in megacities.
Thank you, Doug. And Sherry doesn't need an introduction, but Sherry, it's up to you to introduce your staff if you wish, because you guys are really important and you can cut us off any second.
So I just wanted to say hi. I'm Sherry Cooper. I'm the administrative officer for the Rosenberg Forum. And I have Caitlin Sutherland, who is our new event specialist, helping us today, and Clint Zhu. And Kelly's picture is showing here, but that was my error. So they are here and they are working hard to help the webinar go forward. Thank you, Suresh.
Fantastic. So without any logistical information you wanted to pass on to people, I don't think everybody's familiar with what needs to be done at this point. Without any further delay, I turn the meeting to Christina Babbitt, who has really put a lot of effort in trying to put this together with a number of the colleagues from the board. And Christina, it's your program. Thank you.
Thank you very much, Suresh. As we get started today, if people want to just enter in chat where they're calling in from today or introduce themselves, that would be wonderful. But I'm really excited and honored to moderate today's session, which will review the current state of groundwater globally. And we'll also explore case studies that highlight cross-cutting challenges that declining groundwater levels pose to populations living in megacities around the world. So where I'm sitting today in California in the US, we depend on groundwater for around 30 to 40% of California's water supply. And this increases substantially in times of drought when surface water is no longer available for use. So of course, as many of you know, groundwater is an invisible resource that is too often ignored, and yet its existence is critical to sustaining people, nature, and economies. So today, I'm very excited to hear from three esteemed experts in the field of groundwater management. Our session will be composed of 2 talks and a documentary video presentation. Before each speaker, I'll provide a brief introduction, and then you can find more information about their bios on the Rosenberg website. So without further delay, it is my pleasure to introduce Dr. Stephen Foster, who will help us better understand the state of groundwater globally. Dr. Stephen Foster currently serves as the International Water Association Groundwater Management Group Chair, and he has held an array of prominent positions ranging from Senior Advisor for the Global Water Partnership, Team Director for the World Bank Groundwater Management, and Division Director from the British Geological Survey. And my notes are a little bit different than I think this slide, so you'll get even more of an array of his background. Dr. Foster has also received many awards and honors, which you can learn more about on the Rosenberg website. So thank you so much, Dr. Foster, for being here with us today, and I'll turn it over to you.
Thank you, Christina. Yes, hello, everybody. It's a great pleasure for me to start this webinar on groundwater in megacities. I'm very pleased that the Rosenberg Forum picked up on this subject, very appropriate, this being the UN Year of Groundwater. And for this presentation, I'd like to mention two professional associations, the International Water Association, whose groundwater management group I currently chair, and the IH, whose urban groundwater network I co-chair. And they contributions from various people in those groups have helped to put this picture together. Next, please. Groundwater and cities have an intimate relationship, but one that's rarely recognized. I've tried to depict it here in this small cameo with the freshwater side in blue and the wastewater side in red. And as you can see, there are many linkages. There are important differences in those linkages depending on the local geological conditions and whether aquifers are confined or unconfined, and on the water and supply and sanitation arrangements. And next, please. Groundwater is now known to be critical for the economical provision of water supply in innumerable cities and towns globally. And the current estimated dependent population is put in the order of 2 billion. Those figures are not all that reliable. Demand is always exacerbated in drought and under climate change scenarios. And local groundwater use wherever feasible is a key coping and adaptation strategy to climate change. But rapid, uncontrolled urbanization is placing groundwater under increasing risk due to excessive exploitation and pollution. And this results in growing concerns over groundwater quality and potential impacts on human health, and also yield failure or reduction in many shallow water wells. Next, please. Now, this is a two-way process. Groundwater is impacted by urbanization, and urbanization is impacted by groundwater use. And we don't have time today to look at all of these things in detail, but I'll just give the scope of this. On the whole, in urban areas, you have increased resource availability because of recharge from water mains, seepage from in situ sanitation, despite land surface impermeabilization. But you have quality degradation from various processes. Also, if groundwater is being used, it can impact the urbanization infrastructure. There can be damage to land subsidence after intensive abstraction of falling water table, and infrastructure damage as a result of drainage problems and uplift should water well abandonment subsequently occur. Next, please. I'm first going to deal with urban groundwater and how we're trying to confront, on some success stories in confronting the impacts of intensive abstraction. Next, please. Within the urban limits, there are rarely sufficient groundwater resources to support urban water utility requirements, and quality threats are also a concern, and thus there are nearly always some sustainability issues. But staged low-cost development has historically been feasible and usually resulted in lower tariffs and better service levels. And the development of conjunctive use of groundwater and surface water is highly recommended, but there are numerous impediments that have to be faced. Next, please. I'll go first to Lima, where in the late 1990s and early 2000s, there was a successful application of demand side and supply side management measures to confront a serious situation. Lima is underlined by a major but not very thick aquifer, and it was heavily developed for public water supply. As you can see on the blue trace, this resulted in quite rapidly falling water levels and concerns about lack of water supply. These are further aggravated by the fact that the river in Lima is heavily polluted with mining waste from upstream in the wet season and is not treatable. So groundwater is essential for supply of something like 8 million people during the wet season at least. So what was done on an investment mobilized in part through the Inter-American Development Bank, the World Bank, was to enable nearly all the consumers in the urban area to be supplied both by groundwater and surface water, depending on availability. The main river tract where recharge occurs was improved and increased the recharge there. And a lot of construction was much better controlled. And as you can see, from about 1991, the water level stabilized at a groundwater abstraction of 720 megaliters a day on average, of which 320 is private. And this is quite a success story for a country which is not one that has had many environmental management success stories. And it was done by an unusual arrangement in terms of the institutions, with the government empowering the water utility to construct a special department for this work. Next slide, please. Another success story is Bangkok in Thailand, which was from the 1980s onwards, was threatened by rapidly decreasing water levels and a lot of land subsidence in an area which was prone to flooding from the sea. And what happened here was more conventional in the sense that the powers of the water regulatory authority were strengthened, and a variety of measures were taken, including a partial ban on new water well construction, closure for some existing water wells, alternative sources of municipal water supplies, and metering and progressive charging for groundwater use. And this succeeded in stabilizing the aquifer condition in the late 1990s, and it's remained that way with some subsequent recovery. So two success stories of getting groundwater on a sustainable footing in developing cities. Thank you. Next slide, please. However, groundwater is also very significant volumetrically for in situ private self-supply. This greatly complicates the management equation where that occurs, and it's a major issue in Southern Asia, Sub-Saharan Africa, and parts of Latin America. Next slide, please. It's a fast-growing phenomenon in urban areas where water well construction is of low cost, even when the aquifers are not all that prolific in terms of yield. It improves access and reduces costs for some groups of users, and represents a coping strategy initially, and very often a cost reduction strategy for those users in the longer run. It could be considered as reducing demand on and recovering mains leakage from utility water supplies, but it's much more complicated than that when you dig into the detail. Next slide, please. My example here is from Fortaleza in Brazil, of which about half the population have water wells into dune sands. They're capable of providing about 40% of the total supply. And particularly all these high-rise blocks, the apartment blocks that you see in the photograph, tend to have high-yielding tube wells. And they're used these days to substitute utility water when their consumption exceeds the social tariff. And there are consequent difficulties in administering the whole water sector in the city. For example, it's low-lying and largely sewered, And if people self-supply from their own wells, how do you pay for the sewerage? And they've now introduced measures whereby the water utility can collect sewage charges from all water users in relation to the size of their property, recognizing that an awful lot of sewage is developed through private groundwater abstraction. And this is becoming a global problem. The worst city of all in the world in terms of the proportion of the total supply provided from groundwater privately is Lagos in Nigeria, where it gets up to about 75%. Next slide, please. So this, as I say, private domestic self-supply distorts utility water operations and has implications for their finance and investment. It may encounter sustainability problems and also can represent a public health hazard because it's poorly monitored. But banning such practice is too simplistic, except where there are major public health or environmental hazards, and complex management measures are needed. Enhancing recharge, reducing pollutant load, improving construction standards of private water wells, and for in situ sanitation, advising users on potential hazards, charging and regulating for groundwater use. And in cities with this phenomena, the struggle to sustainably manage groundwater is much greater. Next slide, please. Now, I want to look at the quality issues and the contamination threats, in particular, managing the nexus with sanitation. Next slide, please. Wastewater via in situ sanitation, sewage leakage, wastewater reuse, spillage of industrial chemicals, ground disposal, and also solid waste disposal represents a common groundwater contamination threat in many environments. Its actual impact varies widely with the natural vulnerability of groundwater systems, but nearly always in situ sanitation on a large scale results in excessive nitrate loads or nitrogen loads and fecal pollution. Next, please. My first example here is from Natal in Brazil. This slide is a little bit small, but as you can see, the city has grown very rapidly from its size in 1984, just the small area marked by the blue arrow, to 2006, all of the red areas, and it overlies an excellent but relatively thin aquifer. And on the southern side of the city, as you can see in the other diagram, the groundwater nitrate concentrations are in excess of the World Health Organization limits in nearly all of the downtown areas. And this is a result of in situ sanitation mainly. Next slide, please. If we're talking now about sewage sanitation, we have to look downstream for the problems created with groundwater. There are 4 examples here. And the quality of the wastewater is in the pale orange circle above. And the good groundwater is in the bottom left-hand corner. But many groundwaters downstream of cities that are sewered. In this case, it's the downstream of Mexico City, the Mezquital area, Leon, Mexico, Hat Yai in Thailand, and the Wadi Dulail in Jordan. There is a significant contamination, both in terms of salinity, nitrates, organic carbon, and other things. And this is perhaps the biggest outstanding challenge for groundwater in and around urban areas. Next slide, please. You tend to see in developing cities in particular, these are on the top left-hand corner, typical wastewater being let out in canals for irrigation because it's considered a valuable resource, and then applied with flood irrigation, often to very poorly protected wells. This one is in Mexico. It's a major well for public water supply. As you can see, there is wastewater irrigation almost up to the wellhead. Next slide, please. And so for where we do have sewage sanitation and wastewater reuse, groundwater protection involves improved spatial planning and use controls. And the small pictures that I've put in there show that the better arrangements, the more secure arrangements, are ones in the lower of the 2 sections, where industrial wastewater is led off elsewhere and separated and not mixed. And the domestic wastewater goes to recharge lagoons and then may be used via wells for irrigation with more security. And the public water supply should be outside of these areas and protected in a spatial sense. Next slide, please. I've talked about the conflict. It's not an easy one to manage. And even perhaps in terms of better sanitation, dry eco sanitation systems with urine separation offer the best type of solution, but you can't retrospectively fit these. So very often the way forward is construction of external well fields within municipal limits, but they need the areas to be controlled around them against an uncontrolled urbanization. And they need much better protection. And they also need separation from the main sewer outfall areas. Next slide, please. So let's just have a brief word then on something I don't think we're going to deal with much today, which is the control of impacts on urban infrastructure of groundwater use in urban areas. Next slide, please. It's an evolving relationship, that between groundwater and the city. It starts with tendency in the upper of these three sections to be falling water table, possibly land subsidence, and other problems for the urban infrastructure and well reductions. But as the cities grow and water utilities wisely go outside and collect their groundwater from peri-urban well fields, then you can get rebound. And here you're seeing rebound coming up. And in the end, in the lowest picture, causing problems for the infrastructure of the city itself, uplift problems on properties and drainage problems that you can see in my lower picture. So these are some of the environmental problems associated with poorly managed groundwater use and then abandonment in urban areas. Next slide, please. So this is my last slide, and I'll just take this a little bit more slowly. Urban groundwater, we need an integrated vision. We've got to see all these facets and how they interact. It's always more significant in overall water supply than appreciated, and often the invisible link between various facets of the urban infrastructure. Urban groundwater, therefore, should be managed, even if no major utility supply interests exist. And a casual laissez-faire approach is often costly and hazardous. Urban groundwater affects everybody, but tends still in many places to be the responsibility of no specific organization. Broader stakeholder involvement, therefore, is essential, but who should take the management lead? And here, obviously, in the classic model, it would be the Water Resource Regulatory Agency, but very often they do not have enough capacity to do that, and you need greater involvement from the water utility, the municipal authority, and the public health ministry. And some sort of permanent sitting group of these bodies is probably the best way to advised by people who have a good understanding of the resource, is the way to take the management forward. So I think that's my last slide. I thank you for your attention. Thank you. Next slide, please. And that's my website and my ResearchGate publication list, should anybody want anything specific from there. And I believe there might be time, Madam Chair, for a couple of questions at this stage.
Thank you so much, Dr. Foster. It's really amazing to hear stories from around the world, definitely very significant groundwater challenges. And I also very much appreciate your attention to some of the solutions, which we often don't hear much about. So thank you very much for your talk. And we do indeed have just a couple of minutes for questions. So I'll go ahead and ask the questions that were posted in chat. And if others have questions, please put them there. And then for the discussion period at the end, we'll open it up a bit more. So the first question comes from Sedur Rahman, and he mentions that it's good to know that Bangkok's land subsidence was studied. As well, in the 80s and 90s, other Asian cities such as Dhaka and Manila were also vulnerable to land subsidence due to huge groundwater extraction. And they're interested in knowing if you have any reports on mitigation strategies for these cities or what resources might be available.
Yeah. Well, yes, you're right. There have been numbers of Asian cities, particularly on thick recent alluvial deposits that have been troubled by uncontrolled exploitation and land subsidence being one of the consequences. And when they're in a coastal situation, it's doubly dangerous because of the increased risk of flooding of from the sea. The approach taken in Bangkok was conventional in terms of institutions. It was the regulatory agency that was given increased powers to address and talk to all the users and negotiate with them on an agreed policy from the national government. And it worked. You saw my graph there. It took about 4 or 5 years, maybe 6 years for them to get the total abstraction into a new balance and to control it. There were problems along the way. They immediately tried to, they immediately told the Metropolitan Water Authority that they had to import their water supplies from surface water at long distance. And that greatly increased the water, and and therefore many private companies and apartment blocks and so on wanted to carry on abstracting groundwater. And this process of negotiation and reducing the abstraction in the worst areas was a lengthy one, but it's one that worked. And there's no other solution. You've got to get to a level of abstraction which curtails the phenomena and secures the position. And as I say, in the case of Bangkok, it was done in a conventional way in terms of the institutional plan. The other example I mentioned, which was Lima, was unconventional. At the time, the concern there was not land subsidence. There was no significant land subsidence. The concern was that the aquifer, which was not that thick, was rapidly emptying, and they would run out of their groundwater supply, and therefore would have no water at times when the surface water was untreatable due to suspended solids from mining waste. And what they did was they spoke with the most organized local agency, which was the water utility, Sedapal, and gave them the authority, and they set up a special office to manage the Lima aquifer in the interests of the entire population. And again, they succeeded on a time basis of about 6 or 7 years by, in this case, eliminating many of the industrial abstractors, getting everybody able to receive both surface water and groundwater when it was available, and more charging and rationalizing the use. That's more or less my comment. I think the challenges for management are institutionally bigger than they are technically.
Agreed. Wonderful. Thank you very much for that response. I think in the interest of time, we'll move to our next speaker, and please keep the questions coming. We will address those during the discussion phase. And if others in the audience have responses or thoughts on any of the questions, please feel free to start a dialogue. So thank you so much, Dr. Foster. So our next speaker today is Dr. Ricardo Hirata, and he will present on groundwater in megacities, a Brazilian perspective. Dr. Hirata is a professor at the Institute of Geosciences at the University of São Paulo, and he is the director of their Groundwater Research Center. He is also the vice president of the Brazilian Groundwaters Association. Dr. Hirata has more than 36 years of experience working in more than 30 countries on issues of groundwater contamination, development, and governance. And he was previously a member of the Groundwater Management Advisory Team at the World Bank, among many other prominent positions, which you can go to the Rosenberg Forum website to learn more about Dr. Hirata's background. Thank you so much for being here today, Dr. Hirata, and we're excited for your presentation. The floor is all yours.
Okay, thank you. Thank you, everybody. Good morning, good afternoon. From Brazil, it's good afternoon. Lunchtime, actually. And I want to start sharing my screen here. Okay, great. Technology is working. Okay, great. Thank you for the introduction, Christina, and thank you for the organizers to give me this opportunity to discuss the situation and also the perspective of the groundwater in Brazilian megacities. And while I'm speaking particularly about the São Paulo metro, the metropolitan area, the place that I'm living, that it is strongly dependent on the groundwater for supplying a population of 22 million inhabitants. That's the total population of these metro areas. Groundwater is a vital resource for Brazil, and groundwater plays an essential role in supplying cities and also the rural areas. Well, it's necessary to say that Brazil is the sixth most populated country in the world, with in total we have 220 million inhabitants. That represents 87% living in cities. But also the country is one of the most important agricultural producer in the world that use much more surface water, but now groundwater is getting more important. And the country is the ninth most user of groundwater that extracted through 2.5 million tubular wells and plus 3.5 million dug wells in the springs, mainly in the rural areas. However, this importance doesn't not translate directly into policies and protections, and I show it during my presentation. And mainly one number that I like to mention is that 78% of the tubular wells are illegal. It means without license or even are clandestine. Surface water supplies 82% of the population in terms of public water supply in cities. However, it's essential to recognize that the groundwater supply 52% of the cities. It means that most small and medium-sized cities is totally dependent, or is strongly dependent on the groundwater. And it means that groundwater is a very significant resource for these small and medium-sized cities. However, the importance of groundwater for cities is also associated with the complementary supply to public mains. And sometimes this importance is hidden by official statistics. That's the reason that I want to present the case of the São Paulo metropolitan region. This is the location. São Paulo is just under the Tropic of Capricorn. Here is the southwest of the country, pretty close to the coast. Well, the Metro São Paulo has a population, as I mentioned, 22 million inhabitants. Public water supply, the total system, that's a very complex system of tunnels, treatment plants, and reservoirs. That's a very, very complex, that's provide to the city 64 cubic meters per second. It means that the total water, almost total waters, comes from surface sources. However, the metropolitan region has 13,000 private wells. That's in total extract 11 cubic meters per second. That means that for Brazil is one of the biggest cities that depend on the groundwater. It means that instead of 1%, consider that the 99% of surface water, actually groundwater plays a much more important role and represents 17% of the total water that the city needs. During the droughts, the last two droughts, this number reached up to 25%. That's the problem is that when you consider that the city is really dependent on the private wells, is also our concern is that 60 to 70% of the wells are irregular or clandestine. São Paulo is a little bit better than the rest of the country, but it's still a really high number in terms of illegal or irregular wells. It means that the water security of the city depends on no regulated wells in a very big sense. I can say that if private wells didn't exist, São Paulo probably could collapse in terms that we don't have 10, 11 cubic meters per second extra to supply if something happened with these private wells. And groundwater, because of this situation that is not official in terms of supply, groundwater is not considered properly in the water resource plan. Well, what's the moral of the story so far? Groundwater is hiding behind the official statistic beyond the perception of society and the water resource management. It is in the private supply that groundwater makes a difference in São Paulo, but also in Brazil, and I can say that in Latin America. And that is, we are behind or covered by the official statistics. Well, there are two main, but I think around the world. The first one is overexploitation, and uncontrolled groundwater extraction results in declining aquifer level, loss of water efficiency, increase the water cost. The second is problem of contamination, and I like to point out the problem of nitrate extensively affected the aquifer below the cities. Even in the case of the case of the São Paulo and in my states, that the coverage of the sewage network attended, for example, 96%. It means that the problem is not we have the sewage network, the problem is leakage, but because of low maintenance. And also, of course, São Paulo has a very long story of industrial plants and development, and the chlorinate solvents are another big problem. It's very persistent in groundwater and is very toxic, and also heavy metal. That's much more local in some places of the city. Well, the impact of unplanned and uncontrolled extractions, although there are areas of intense exploitation and strong hydraulic interferences, sometimes we have lowering more than 100 meters in aquifers, the medium-sized aquifer, that's in an average 150 to 100 meters. It means that in some places you lost more than 2/3 part of the aquifer. And the people is still working, is still extracting the water. And it's interesting because this problem of over extraction is compensated by the leakage in from the public water and the sewage network that recharge the aquifer. A calculation that we made, my group at the university used isotopes, stable isotopes, calculated that 60% of the water comes from the network, the mains, the leakage from the mains, and the 40% from the direct infiltration in the green areas, that's part of that, but also from the leakage from the rain water drainage network. It means that the majority of the water that is still feeding the aquifer in São Paulo comes from some anthropogenic activity associated too. It means that the cost, the people are still using the water instead of to have this high hydraulic interference, because still the private wells extraction is 3.5 times cheaper than the water offered by the utility. And I have to mention that the service, the public service, is pretty nice. I think that 99% of the population, and the quality of water is pretty reasonable, is drinkable water, nice quality. But because of the price, people still using a lot of groundwater. To address this exploitation problem, we define a methodology to identify critical areas associated with overexploitation. We divided the region into squares of 2 kilometers by 2 kilometers, and after detailing 500 meters by 500 meters, it means that you have a lot of these squares, and count the number of the wells and sum the extraction of each of these cells, and to recognize areas that have high values of extraction or density of well, and consider this as a critical areas, and try to reduce the new drill wells in these places. And these two maps represent, this is dots represent the areas that the groundwater has to be restricted. In terms of contamination, regular contaminated area management conducted by the state of São Paulo government has a very, very nice, excellent protocol to identify the areas to manage this contaminated area. So far, we have more than 6,000 areas that were declared contaminated. It means that monitoring wells were drilled, samples were analyzed, etc., etc., etc. Risk analysis were made. It means that a complete study to understand the situation, and you have this in 6,000 areas. And in some places, you have the final remediation phases in more simple cases. We believe that the using this potential contaminant load inventory that I mentioned previously, but apply in terms of contaminated area, we believe that we have 70% more contaminated sites in the region, and that you have to discover. We propose to identify potential critical areas using this approach that I mentioned, and to identify this higher probability of soil aquifer contamination. That's to implement these strategies. That's the map, using the same approach of the squares of starting 2 by 2 kilometers and after 500 by 500, and also places that were declared contaminated. And we had a very good correlation between the contaminated area, proved contaminated area in this methodology, and we are using this to help the environmental agency to hand the groundwater use in these places. Speaking about the irregularity of the exploitation of the private wells in the case of the state of São Paulo, but also in the region of the metropolitan area of São Paulo, we conduct an opinion poll direct at the stakeholders, and we had 275 respondents that indicated the irregularity of the wells. That is our big concern, is due to the people consider that the legislation is good enough for 84%. However, there is a lack of surveillance inspection in law enforcement for 71%. It means that we have a good law, but not well applied because of the problems of institutions or incapacity of the government institutions to apply this law in 64% of the cases. Another interesting result was that users see no problem in having regular wells for many reasons, for 71%. And nothing will occur to them because of the irregularity of the wells. It means impunity in 59%. People just say, okay, it's a not so big concern to have my irregular wells, and if something happens in the future, it's no problem either. Users do not perceive benefits in having regular wells. It's interesting because the government cannot transmit the idea of how important it is to have regular wells. Actually, the users say, okay, I have to pay more just to have the wells, but I don't receive anything in return. Lack of knowledge about the aquifer functioning. They don't understand the function of how the aquifer works, and the exploitation conflicts. They don't understand conflicts, the cause and consequences of the conflicts in terms of 63%. Sometimes you have conflicts in the region, but nobody understands that's really a conflict because they don't understand how the aquifer really works. Actions to reduce the irregularity. Based on these results, we understand that mechanisms to regulate illegal wells must go further to the command control approaches. That's the traditional and the base of our law and our regulation. And we must introduce other mechanisms if we like to overcome extraction problems in developing countries like in Brazil or even in Latin America. To do that, we consider this triangle with 3 pillars. One is the classical command and control mechanism that obligate users to regulate the wells by police control. But we, as I mentioned, we know that without surveillance inspections and law enforcement, this doesn't work adequately. Mainly in countries like Brazil, in Latin America, with a long story of weak institutions and democracy problems. In this way, we have to consider the second pillar, that is user awareness. In this case, it means that convince irregular users that irregularities or problems caused by the uncontrolled extraction brings losses to the users and to everybody, including increased cost, investment loss, etc. It means that that's the motor to convince people to be regular because of the problems of conflicts or problems of increased costs and losses. And in this case, some mechanisms is, of course, much more connected to communication, to user groundwater education. That's, of course, is very, very difficult because it's a typical tragedy of commons, and identification of individual losses and conflicts, and information addressed to the users. It means that a strong communication program from the government or even for the utilities. And the third one, as user awareness, is we understand that it's a key factor for that, but also we need to introduce a program of benefits to regular users, or having regular wells is more advantageous to everybody. It means that we can provide service, provide facilities for the users to be regular, and create an environment when regular wells are more attractive than irregular wells. For example, many private users use the sewer service but do not pay for that. This is because the calculation in Brazil, in many other countries, of how much you have to pay for the sewage service is dependent on the water that you consume. For this, the utility install a hydrometer in the well. Unfortunately, clandestine wells do not have this possibility, and if the user declared that, for example, that has a well, the utility or government could provide service instead to get this regulation. It means that is a possibility to implement this more the regulation of the well. Well, at the end, my final conclusions, that my last slide, groundwater is more important than the perception of the society and the managers, and the conflicts are little perceived by the users who don't push the government for control measurements. That's a vicious cycle. And although command control mechanism is the basis for the management, bottom-up instruments should be incorporated, mainly in the case of Latin America and Brazil. Commencing legalization.
I think we are experiencing an issue with Professor Harada's internet. So
Thank you very much for your attention.
There you go.
And
Sorry, Professor Harada, you actually froze for just a second. So we couldn't hear you for like the last 5 or 10 seconds.
The timing was actually pretty ideal because you only had one bullet left. So we made it through your presentation though, and you just froze at the end. Thank you so much. No worries at all. We all know well about internet issues these days. But thank you so much for your presentation. It's really fascinating how perception comes into play in groundwater issues. It's already an invisible resource, and then when it's not recognized as a resource, that makes the challenges of addressing the issues even more difficult. So thank you so much for your presentation. And in the interest of time, we're going to move forward with our next speaker. For our final presentation, it is my pleasure to introduce Nick Kausar. Nick is an Iranian cartoonist and geologist who is well known for warning Iran's president in 2001 about the effects of the country's distressing groundwater management practices. Now residing in exile, Mr. Kausar produces a weekly show about water scarcity and appears on mainstream TV channels as a commentator and expert about Iran's ongoing water crisis, and is also a writer of major online publications. Mr. Kausar has worked tirelessly to produce the documentary that you will see today, and we are extremely grateful for all your efforts and your time, and thank you so much for being here today. The floor is now yours.
Thank you very much, Christina, and thanks to Surush for encouraging me to focus on this matter and inviting me to this wonderful event. I think if we can start with the video, I intended to just produce a report, but it turned into a documentary. So I'm very happy to present it right now, and I hope I don't want to say you'll enjoy what's happening in Iran, but you'll enjoy the video. Thank you. As you may have heard, I was once a professional cartoonist, and cartoons should give you a clue in a few seconds about a topic. But let's go to the bottom of this at the end of my unusual presentation, and I'll add the caption to the cartoon in just 20 minutes. So please bear with me. I'm going to tell the story of the impact of groundwater depletion in Iran and talk about two major cities. Yes, we have lots of hotspots, but let's just focus on two of them for the time being. First of all, what do we know about Iran and its aquifers? Let me channel through my dad.
Iran is facing a serious water crisis, and after that we would have food crisis. The reason for this dire situation is the shortage of water all around. Iran is in a very dry zone of the earth, and we receive about 1/3 of the average world precipitation. Therefore, we have to be concerned with the amount and timing of water that we receive. As about 60% of our water needs is supplied through underground, we have to manage our aquifers very carefully.
Old Persia was once the land of hydrogeologists who could drain a limited amount of groundwater without depleting the aquifers. Many consider the Persian civilization the Kariz civilization. Qanat or Kariz is a system of transferring water from an aquifer to the surface through a gently sloped tunnel.
Qanats are hand-dug tunnels that begin in the foothills of the mountains and wind gradually downhill to bring water to the homes kilometers away. A horizontal tunnel with a gentle slope that partly cuts through the aquifer. The slope was quite sensitive, as if it was too steep it would wash away the tunnel, and if it was not steep enough the water wouldn't flow. So it was quite an art to make these qanats.
Qanat is known to be the most sustainable means of transporting water in arid zones, as it limits evaporation. Old Persian water managers understood this. So what happened to the land of sustainability? What went wrong that forced many villagers to leave their homes and lands in the new Iran? This. And most certainly this one. More than 90% of Iran's renewable water resources are consumed by the agricultural sector. Most of the water needed for farming comes from aquifers. Also, some power plants have drained groundwater resources like this one near Hamadan, which was once a water-rich area. Now let's see what farming and power plants could do all together to a plain like this in Kabdarahang near Hamadan.
دور سال 80 بود. قرار بود ما بیایم اینجا زمینه رو شخم بزنیم. اومدیم صبح سر زمین تراکتورها رو بندازیم، دیدیم بله زمینه نزدیک 30-40 متر دهنیش بود. رو به پایین نزدیک 70-80 متر عمقش بود.
After World War II and the commencement of Truman's Point 4 plan, many Iranians were introduced to deep well drilling machines and powerful diesel and electric water pumps. In 1963, the late Shah's land reforms gave many peasants a chance to own their own lands. And through the loans provided by the banks, these new landowners were able to dig wells and purchase water pumps. This enabled the farmers to extract groundwater individually, and each farmer extracted as much as he wished. Lack of supervision and failure to enforce laws and regulations gradually depleted the aquifers in many farming districts.
In the past 60 or 70 years, we have overexploited our aquifers to the tune of, on average, 7 to 8 cubic kilometers a year. Therefore, we have to replenish this water. If we continue using this much groundwater, we are going to end with dry aquifers and mass deaths of our people.
While the Shah liked building mega dams after falling in love with the Hoover Dam in 1949, some officials neglected the fate of groundwater resources. Before the 1979 Islamic Revolution, farmers and water managers dug almost 80,000 wells all around the country. Gradually,
Obtaining digging permits was harder for farmers, but it got much easier after Ayatollah Khomeini and his pupils came to power. They encouraged farmers to produce grains without regard for water consumed in the process. Many farmers dug wells without any permits and exploited the aquifers beyond the system's balanced inflow and outflow of water. This was a bad sign. The Iranian government also followed the path of building dams. This time, it was on steroids, and groundwater depletion had become a new normal. The new leaders were obsessed with mega dams. For them, it was a sign of power and prosperity. In the spring of 2001, I wrote 2 op-eds criticizing the Khatami administration for its water policies and building too many dams without understanding the consequences. The president summoned me to his office, and I met him 3 days after his re-election to explain my points. I took my father with me. We told him that his administration's concerted efforts towards dam building and interbasin water transfer blatantly disrespected Iran's aquifers and ignored the warning signs that would have a very negative impact on the country in the next decade. His government took our points seriously by ignoring the warnings and censoring me. In the next decade, thousands of villages that once relied on qanats had lost the battle to wells and water pumps. With no water and plains becoming victims of subsidence, millions of farmers left their homes and lands to settle in shantytowns.
We have water shortage in many places, in hundreds of villages which are short of water. In the old days, they used to be supplied by qanats or qaris, but most of them have been dried due to the overexploitation by powerful pumps.
Isfahan is now one of the major hotspots of land subsidence in Iran. The aquifer beneath the Isfahan-Bukhar plain is half empty now and is on the path of demise based on assessments. The dry bed of Zayan Darud, the major river that passes through Isfahan, became a political hotspot in November 2021. Isfahan, once the capital of Persia, is now a sinking city. The jewel of central Iran has experienced many droughts through history. Still, its water managers before the last century used its resources wisely and sustainably through the ages to save it for the very generations that are witnessing its destruction. After World War II, the government's water managers transferred water from one of Karun River Basin's tributaries, the Kuhrang River, to Zayan Darud. Later in the 60s, the government built a major dam to store water and regulate the river. This excessive amount of water was seen as a sign of wealth. The area under agriculture in the Zayan Darud Basin expanded, and many farmers began to cultivate rice and wheat. The government inaugurated the country's first steel plant in the arid central Iranian plateau, only relying on the flow of Zayan Darud that was receiving constant doping shots from Karun. After the 1979 revolution, a second steel plant that was first supposed to be built near the Persian Gulf was established near Isfahan, stealing more water from the basin to produce more steel. From 1998, a major and long-lasting drought started, and because of overconsumption and decreasing rain and snow, rivers such as Zayan Darud shrunk. Zayan Darud, which originates from Zardkuh in the Zagros mountain range, is the most critical and strategic river in the central Iranian plateau. People settled near this river, and the city was born thousands of years ago during the Bronze Age. In the past, the annual flow of Zayan Darud was around 1.4 billion cubic meters, and out of that 1.4 billion, 650 million cubic meters was from tributaries and groundwater, and the rest was and has been transferred from the Karun Basin. The government is planning to transfer more water from the Karun Basin, and that is going to cause major problems with people in other provinces. Consumption of drinking water and sanitation has increased from 60 million cubic meters to over 400. And part of the water is being transferred to cities like Yazd and Kashan. Industries draw about 70 million cubic meters of water from the river and use the rest from wastewater treatment. The defined consumption for the Zayanderud River is about 1.5 billion cubic meters, while the river has an average of 1.1 billion cubic meters in the last few years. And last year, it became much less. So the rest comes from aquifers. After the drought struck in the late 90s, farmers who didn't want to change their routine started digging more wells and extracting more water from under the ground. The balance between the aquifer and the river was gone, and later signs of land subsidence appeared. A network of canals called Madi channeled water from the river to farms and orchards in the past. After the drought and transfer and consumption forced Zayanderud into its disappearance, the city dug a few dozen emergency wells. Madis were essential in recharging the aquifer, and now they're dried up. Over 5,400 wells in the Isfahan-Burkhar plain have become the only options for farmers. Half of the 1.7 billion cubic meter aquifer is now gone. Under today's regime of overdrafting, the aquifer will most likely die in the next 9 to 15 years. And through time, this has caused subsidence in the area, from a few millimeters on the edge of the Isfahan-Burkhar plain and aquifer to almost 18 centimeters per year in the middle of the plain, where people are feeling the heat, with a gradual destruction of their homes. Many have had to evacuate and leave. Recently, an official from the Ministry of Roads and Urban Development told me that considering the presence of active faults in the area, Isfahan is now turning into a high-risk city after thousands of homes have been affected by land subsidence. Reza Islami, the head of Iran's Geological Survey in the Isfahan province, says that the continuation of this situation and the exploitation of the aquifer will damage more than 6,000 historical structures, including old mosques, homes, and bridges in the city of Isfahan.
فرض بکنید الان زلزله بم افتاد دیگه. اگه شما اون موقع اینا میدیدی چی میگفتی؟
گفتیم ممکنه زلزله هم اینجا اومده باشه.
آره یعنی واقعا
اینجا رو باز من عنوان نمی‌کنم. دوربین رو بچرخونید اونور. اینجا قطعا میگفتم زلزله است.
قطعا میگفت. اگه عامل زلزله نیست.
حالا چه اتفاق افتاده اینجا؟ وقتی زلزله میاد من امید به بازسازی دارم. ولی وقتی که فرونشست اتفاق میفته مفهومش که اون دشت رو نگاه کنید خوش شده. یعنی من امیدی دیگه دوباره به ساختن این دیگه نخواهم داشت. تفاوت این دوتا یه تفاوت اساسیه.
درست.
یعنی ما ساختگاهی رو داریم که فقط بنا توش از بین رفته توی زلزله، ولی توی فرونشست ما ساختگاه رو از بین بردیم و بعد بنا رو. اینها دوتا اختلاف کلی با هم دیگه دارن. به نظر من زلزله یک همه رو خاموش میکنه.
دقیقاً اتفاقی که ما میگیم تو 1409 که خوشبینانش 1416 باشه که آبخوان آبش تموم میشه، اتفاق برای اصفهان خواهد افتاد.
ببین اکثر اونها صبح هم ما صحبت داشتیم دیگه، با شهردار محترم دامنه صحبت داشتیم، اینها اکثرا رسیده به کف، یعنی عنوان میکنن که اینجا کشت اضافه شده و در این حال دفعات کشت هم اضافه شده. یعنی درسته ما بهره‌وری رو انجام دادیم ولی میزان مصرف به حدیه که از میزان کاهش یا راندمانی که بر بهره‌وری ایجاد کردیم باز هم میزان مصرف بیشتره. پس بنابراین اکثر این چاه‌ها تقریبا تا کف پایین رفتن. یعنی ما آبخوان رو تقریبا تخلیه کردیم. اطلاعات ژئوفیزیک هم به ما همین رو میگه. ما 4/5 آبخوان رو تخلیه کرده بودیم تو اون زمان.
تو دامنه.
توی دامنه. پس بنابراین مهم این هستش که زمانی که ما ساختگاه رو از بین بردیم توجیهی برای ساخت هم دیگه وجود نخواهد داشت.
آیا یه سوال دیگه، این ترک‌ها که رو دیوارا هست اینا یهویی ایجاد شده یا قطعی بوده؟ نه به تدریج بوده، یهویی این ترکه به این گندگی به تدریج
ترک ها باز و بازتر میرسه تا برسه به این موضوع.
به این ترک عرضش حداقل 50 سانتی متر، اما بغل ها هم این بغل یه ترک دیگه ایجاد شده، اینجا یه ترک دیگه و همینجوری میریم یهویی هم ترک های حلقوی که سمت حسین آباد ما میدیدیم اینجا داریم میبینیم و یهو این پدیده بسیار عالی یک فروچاله. دکتر 8 متر هست؟ آره دکتر به خدا اگه تناب بود من میرفتم، من اگه تناب داشتی میرفتم توش. آره اختلاف ارتفاع اینجا با اونجا چیز اولش 1.5 متره، یعنی این سطح با این سطح نیم متر اختلاف ارتفاع داره. حالا دوباره ادامه بدیم به حرکتمون، چه اتفاقی میفته؟ دوباره ترک‌های جدید شروع میشه. بله به موازات هم ببینید اینا قدیمیه و اینا جدیده، اینا جدیده، تمام این ترک‌ها جدید.
درزش باز شده، انگشت قشنگ یه انگشت داخل میره.
وای جدی اینجا میخوابی شما؟
بله.
باور کردم
اون پشتتون هم هست اونجا.
اصلا نخواب تو رو خدا، اینجا خیلی خطر داره.
اما اینجا نخواب.
A few years ago, 2 scientists published a paper indicating that between 2003 and 2017, there were 3 distinct subsidence features in Tehran with rates exceeding 25 centimeters per year in the western Tehran plain, approximately 5 centimeters in the immediate vicinity of Tehran International Airport, and 22 centimeters per year in the Varamin plain in the southeast of the capital. Tehran is a megacity with inadequate infrastructure built over an alluvial fan south of the Tochal mountain. For thousands of years, smaller towns and villages relied on a number of streams and qanats. In the 1800s, when the Qajar dynasty chose this part of the country as the capital, many moved to the new center of the Persian civilization. The radical development of the city started after the downfall of the Qajars, and the new king had high hopes to turn Tehran into a modern capital. Between the 1960s and the 1980s, many land developers and house builders began building settlements and suburbs regardless of soil resistance of alluvial fans and qanats, and after the Iran-Iraq War, many skyscrapers appeared all around the city. Seismologists are awaiting the return of a large earthquake, and according to estimates, the death toll from this earthquake may exceed 100,000 people. Although civil engineers were concerned about buildings' resistance to sudden shocks of earthquakes, paid no attention to land subsidence, which has turned into a silent earthquake. Cracks have appeared in many townhouses and condominiums and suburban homes, and sinkholes have emerged all around the capital. Parts of the city are sinking with a record of 25 centimeters per year, close to what we have seen in Corcoran, California. To add insult to injury, cracked buildings and weakened structures due to subsidence will have very little resistance to the large-scale earthquake that awaits them. And this will greatly increase Tehran's risk of destruction. Gary Seek, one of the members of the National Security Council under Ford, Carter, and Reagan, and an expert on Iranian politics, once told me that the effect of a major earthquake and drought is beyond a coup d'etat against the Islamic Republic. I think his statement is true, especially because the regime has not treated water, the planet's most precious gift, with care. There are many solutions. These are a couple of them. Improving agricultural policies, having an integrated water management system, environmental accountability should be there, applying environmental justice, and electing smarter leaders.
The most important activity is recharging aquifers, which have been depleted in the past 80 years. after the introduction of pumps in Iran. What we do, we divert flood water from mostly ephemeral riverbeds and spread it on coarse alluvium, where infiltration is very high. By so doing, not only we charge groundwater, but we make soil thicker, and actually soil building is another part of our project. It is done by nature because the flood water is turbid and we have high rate of erosion on our watersheds. The flood brings a lot of silt and clay and organic material, and we spread it on the ground. By so doing, we actually increase the soil depth, and on sandy land, we stabilize the moving sides.
And here's the caption I was talking about 20 minutes ago. Thank you very much, and I apologize because of the internet speed. You couldn't see it clearly, but I put the link in the comment section so you can just see the video whenever you would like. I should say that during the time I was working on this video, I was talking constantly with experts in the Isfahan region, and it became harder and harder to sleep. I wasn't able to show many videos, and they are scary. And considering Isfahan to be one of Iran's or even the Middle East's oldest cities, it's unbelievable to see how bad water management has actually is actually destroying the civilization over there. And one thing I was thinking about was that how Iran will be grounded as a result of horrible groundwater management. Many rain-fed fields have turned into irrigated fields in the Isfahan region. And because of that, farmers who lost the water coming from Zayan Darud started exploiting the aquifer over there. And the impact, especially in the Isfahan region, is the gradual death of the city. Tehran is also an important example of bad management. And I was very happy to use the knowledge of many experts who are, I think, who are present here, Dr. Akhshanas Hayri and Dr. Motaq, who did the report on Tehran, and other experts who have worked on groundwater depletion. So I'll try to shorten my talk over here, and please shoot with any questions.
Thank you so much for that very moving documentary. I know you put an immense amount of work, and thank you for sharing the story. It's definitely hard to watch, but a story that everyone needs to see. So with the end of Nick's presentation, we're going to move into the discussion phase of our presentation today. And with us moderating the Q&A session are two of my Rosenberg colleagues, Dr. Lucia De Stefano, who is the Associate Professor at Complutense University of Madrid in Spain, and also the Deputy Director of the Water Observatory of the Botan Foundation, and Dr. Ariel Dinar, a Distinguished Professor of Environmental Economics and Policy at the School of Public Policy at University of California, Riverside. And so with that, I will turn the session over to them to moderate the session. Thank you so much.
Thank you, Christina, for the introductions, and thank you to the speakers for these interesting and inspiring talks, and especially the video from Nick. So there has been several questions posted in the chat. Some of them, one has been answered by Dr. Foster, and others have been already addressed by someone from the forum. But anyway, if there is time, we can go back to some of those questions that were already replied. I would like to start with from the end, and from a question that was posted by Catherine. Anyone of you of the speakers could reply. The question from Catherine is about the differences between the use of groundwater or surface water in megacities. The question is which of the two, according to you, is most economically favorable, and what are the different conditions that can make a difference in the use of groundwater or surface water? So if any speakers want to take these questions and give it a try.
If you wish, Lucia, I will just start the reply. I mean, basically, megacities are going to have to use surface water and groundwater conjunctively. The advantages of groundwater, if properly managed, are that it's a lot cheaper and much more reliable under climatic stress. Surface water is usually having been pumped long distances, requires sophisticated treatment and so on. So I don't think it's just a question of which is the more economical. It's a question of getting the balances right. If groundwater abstraction gets out of balance, then there are all sorts of other problems where costs arise. And if you've got very large investments in surface water, but there is not the reliability of the basic source, you can be, despite major investment, with an adequate supply. So it's a question about understanding all the available resources, managing them sustainably, and conjunctively to best advantage.
Sorry, I wanted to include some comments on that. Is it possible? Okay, yeah.
Yes,
I think
please.
that, yeah, okay. I agree with Stephen that, of course, the city, what's the best water depends on how productive is the aquifer and the availability of the surface source in the region close to the city. But it's also important, as I mentioned in the case of the São Paulo, that is not, the groundwater can play an important role as a private, perhaps sometimes not planned or desirable to do that, but it's important to consider that private wells help a lot the water security in many cities, in developing country cities, because there's a very strong private investment that provide extra water for the city. I think that is important to consider that because it is the reality. Sometimes it's not planned by the central government, and neither is desirable for the utility, but it's happened in many, many cities, mainly in South America.
And may I add just one point? Based on what I learned about, especially Isfahan, private wells have destroyed, are destroying the aquifer because there are no regulations, apparently. And after the Zion Darude dried up most of the time, people were taking as much as water they could for agriculture or other uses. So without any oversight, it could be dangerous.
Oh, I also mentioned that it's necessary to control this type of drillings and extraction, but it's a reality that is part of the water helps to the water security in many cities, like in the case of São Paulo. It means that without this water, you are facing much more problems in the last drought that regularly affect the cities. And also, Stephen mentioned some cities, some capitals of the states in the northeast of the country. Recife, for example, is another example. The system that they have is not enough for providing water for everybody. Natal, Fortaleza, there's many others. But of course, you have to control and try to do that.
Okay.
There's one more point I just wanted to make, and that is that it's clear that if your cities are sitting on agricultural plains, you have to address the total abstraction from those systems, and you can't separate urban from rural. It came very clearly across from the case of Isfahan. And where that's the case, you're needing the management of all of the groundwater, not just the urban bit.
Yeah. Okay, Lucia, is it okay if I will take the next one? Oh, you want
Yes,
to...
please. Go ahead. I will take
Okay.
it. We do
No,
one each.
I saw the yellow one. I don't touch it. So I just wanted to say something before I read the question, the next question. And this is, there was a comment made by the last speaker, which I think is very important comment about how bad or how unaware water management practices can lead to disasters, and using the present situation in these two cities, which is only a precursor to what is going on in that country and many other countries. You know, many years ago, not far away from Iran, there was also a problem with salinity, and a very fertile land was destroyed and became desert just because bad management practices. So we are seeing that this, history comes back. So with that, I just will read the next question from Mariana Rivera Torres, and very interesting question. And the question is, what strategies can organizations employ to raise visibility of groundwater issues and incentivize pressure governments to invest in institutions to enforce policies and management actions against short-term economic pressures to keep status quo? So this is for Ricardo and all the rest, of course.
Yeah, I believe is, of course, we have normally the regulations based on the command and control approach. It means that we have a law, regulations, and someone that is responsible for application of this legislation or regulation. That normally is the rule for many countries, and but it's not enough, because normally the institutions are not prepared for fiscalization, for to control the bad use of water, for illegal wells, or to detect, to charge this people who control that. Even in many countries, we don't have the ill for that. It means that the government not say, okay, I don't touch this because it's not the biggest problem, except when it is. We have a very strong conflict that, of course, the state has to work on that. But if you don't have this situation, I think that the other two more bottom-up approach has to be used to convince people or to incorporate more legal wells in the system. One is to programs of communications. That is one important thing, and to show people that future problems may happen to them if nothing be done previously to avoid this problem. And the second, it is, for example, normally people don't understand why they have to do this, why they have to regulate the wells. And because nothing happened with if they don't do that, or even when they do, they don't receive anything. It means that no information, the state is really isolated for the society. It means that you have to construct some bridge, try to say, okay, there is some services that the government should implement to convince people that they have to do that, and they can receive some results for that. It means some benefits. I think that is important to the government, not just to stay, okay, I'm control the water and I have the police and I have the everything, but no, you have to go to the users and try to convince them, offer service, offer information, offer, the possibility to do that. I think that we have to change for more win-win situation and not just the top-bottom system using the policy. That's my opinion.
I would like also to step in because I have also an opinion here. And, economics provides very simple in theory, but also very applicable suggestions how to deal with this kind of a common property like a groundwater. And this is through the appropriation of the water or the water rights and making all the users, all the possible users responsible for each other. And this has worked in many places around the world and could also be a good suggestions for managing groundwater problems in Brazil. One example, and I will stop now, is the Sustainable Groundwater Management Act, the 2014, that is now being implemented in California. And anyone who is interested can go and Google it and learn what is the idea, why it came up, what is the idea about it, and what are the problems of implementing it.
And if I may add something, I know Ariel is well aware of how things are working out in Israel, but one thing that was very interesting for me was visiting kibbutz Hatzarim in the Negev desert, and little children were more aware of water and the water situation and knew about water management than most people in my country or even in different countries. So education would be one important factor. The other thing that I think it's important is to encourage public participation, but without knowledge, this won't happen. And in some countries that public participation would be seen as a threat to the system, it's really difficult. So this is where people like me may possibly be activated or come to the picture by producing material that would cross censorship and giving information to the people about what's happening. 10 years ago, many people thought that building dams was the main solution to the water problem. Now today, at least 60% of the people are critics of dams. So this is something that could possibly happen, but we need to talk more about groundwater, and there's a big gap.
Could I come in? I think that in the two cases success stories that I mentioned, Bangkok and Lima, one important policy decision was that government decided that there was a problem and they were going to make a single institution primarily responsible for the solution of the problem within a realistic time frame. And they communicated that, so people were aware who was doing it and why. Now, in situations like Bangkok and Lima, where there wasn't the issue of a agricultural abstraction interfering, it was about managing urban water use. That worked. The institutions that were named in government policy were resourced and took the lead, and others cooperated with them in achieving a result on a basis of 5 to 10 years. If you have these larger agricultural plains where you've got the big issue of dealing with irrigated agricultural use, it's a tougher problem and requires a different approach. And with the two uses going on, it's very often the agriculture which it causes the greater problem. And this needs a regulated approach on a broader basis. But as I say, there are what's absent in many urban situations is one agency that is clearly been held responsible for improving the situation and resourced to do it. And in the absence of that, you tend to get anarchy. And I think that's still the situation in Brazil. You don't have an institution adequately resourced and charged to take control of the situation.
So thank you to the speakers for these comments. And so continuing with the idea of different typologies of problems depending on the setting, there is one of the participants, Daniel Olago, who asked a very hydrogeological oriented question. So it's about the fact he has noticed that most of the cases that you have presented are about cities sitting on unconfined aquifer systems. So the question is whether you know of any examples from that are of cities that are located on confined aquifers, and the problematics or the issues associated to that specific hydrogeological setting.
I can jump in immediately there, Lucia. Bangkok is a confined aquifer. The aquifer is confined by about 25 meters of very impermeable clay almost over the whole entire area. This meant that abstraction from these aquifers had bigger drawdowns and greater impacts in terms of compaction and land subsidence, and a need for more urgent action because the rates of drawdown were very high. So I think it does vary, but it also meant that because they were confined, you did not have such a large number of small users because the wells were expensive. So it was a more manageable problem in terms of the numbers of people with whom you had to communicate and manage. In cities like the ones Ricardo talked about, where you've got more accessible aquifers, you've got a much bigger user community to deal with.
Okay. But I think, Stephen, I think that we have to comment about the confined aquifers, that some aquifers are not renewable resources, no? And that it means that you have a very limited in time the water, because the water is just in storage. And it means that the replacement of the waters takes much longer time than the extraction. It means that you have to face also this problem. And in this case, is just avoid to use the water is not the solution, because sometimes that water at that specific time, you help a lot to the development of the society in that place, that in the future could permit the society to replace the water for the other source. It means that it's necessary to understand the limitation of this water, how to plan this extraction, and to manage the drawdown to permit to extract more water, but consider that is a fossil or is a limited resource in time. But in this case, we need to understand the situation in a more holistic way, not just look and see just the aquifer. We need to understand other sources and how to replace in time, and what's the opportunities to use the water at that moment. No, that's much more complicated, and you have much more consultations in the society to do that.
Yeah.
And in the Isfahan region, in the Isfahan-Bor power plant, it's an unconfined aquifer, as far as I know, and based on the numbers that I've seen, it's actually losing water by a higher rate than expected, and it should be dying in a way if it's not recharged, and the wells and the pumps are not stopped. It will die between 9 to 15 years. So we should see the total collapse of the city in 15 years unless something changes.
Wow. Okay, and thank you very much. We can move now to another question, and I selected a question that has a different angle, but I think it is a question that can develop some discussion. So this is a question by Keiran Topen. How important is investing in our geological and hydrogeological knowledge of the ground beneath large urban zones to produce sufficient water balance models that can be used to educate landowners or government agencies or bodies, where in some places simply stopping obstruction can lead to devastating groundwater rebound and flooding, or vice versa, as can be seen in Tehran with droughts? So I think this is a very unique, very good question. And I just wanted to, before our panelists are answering it, I just wanted to bring to you attention that in recent weeks or recent time, there is an increase in the number of technical papers that were published that deal with hydrogeological models to explain land subsidence in different locations. Even today, I just received from Google Scholar a message about a new study in the Journal of Total Environment on the Ho Chi Minh City sinking. And papers like that are the sign that there is an investment and there is an interest on the part of our scientists in understanding and increasing our level of knowledge of what is going on. What is missing, and again, this is something that I am trying to advocate for, is not only what is going on in terms of meters or centimeters per year, but also the estimation of the social cost to the population, either directly or indirectly related to those damages. And this is something that we need, in my opinion, to pay attention to, as well as to those models. So with that, I will ask our three panelists to, who are probably more educated than me on developing and investing in geological and hydrogeological knowledge on land beyond urban zones.
I think that these days you will find that the majority, but not all, cities will have an academic center, either a research center or a academic department with fairly good knowledge of the hydrogeological conditions of the local area. Ricardo is an outstanding example in the case of Sao Paulo, but most places have that. The problem is linking those centers to the institutions that are empowered to manage, and using them on a long-term basis to get information into and awareness into the institutional framework. I like the model. In the IWA group, we have people from numerous countries, and I like the model that's been developed in Bucharest in Romania, for example, where the local center of the university has been funded to maintain databases and develop models and make predictions about its the trends in its aquifers in the surrounding region, and the types of problems that are likely to arise, and the sorts of actions that are needed administratively to reduce the likelihood of damage occurring from those problems. So this linking between academic centers and specialist centers and the institutional framework, for me, is the key issue.
Just to add, many people in different parts of the country are not aware that their cities, their towns, their villages were built over alluvial fans. So they have learned about alluvial fans possibly in the last few years because of the news about what's happening to the aquifers. I'm talking about Iran, and the bigger problem is that in many schools, geology is not an important subject for teachers, for the students. It's like something, I don't say exactly overtime, but they don't want to waste their time learning about geology. And that is dangerous, I think, in a country like Iran. And basically educating people through social media as well as mass media is important. And I think there should be more and more documentaries / animations to show how alluvium is important and how the storage that we have over there is precious, and how we should actually manage our alluvial fans and the aquifers. So by that means, I think there should be a major change in the educational system, and civil society has to step in over here.
Yeah, one point that I want to add is that I think although we have some centers that are studying hydrogeology or geology, meaning in geological schools, perhaps our capacity to do that is pretty limited. Even in the government, there are just few professionals that with really capacity to use this information that sometimes is produced in the university and translated to some policies or some instruments for management. In this way, I think that one good approach is to identify critical areas. It means that areas that you have much more problems. And these places, I'm not just speaking about the critical areas just in terms of geology or hydrogeology, but socially speaking, or economically or environmentally, with environment issues. And try to identify these places and try to focus on these places to getting more information and try to understand more, or invest more in terms of time, in terms of money, and the human resources to get more knowledge about how the aquifer works, and also to implement this. Of course, after that, you can go to the other places, but I think that's important to use this type of approach, try to identify critical areas or more important areas in these different aspects. The problem is how to decide what's the area it is, because there's many different concerns or interest, even economic interest, to do that.
Yeah. I don't know, Lucia or Christina, do we have time for more questions?
I don't think so. I've been asking Sherry, and I think that we should wrap up. And I would like to acknowledge that there have been a few questions that couldn't be addressed. I want to think that some of them were answered by the talks of the speakers. Like, for example, there were a couple of questions about aquifer recharge in an urban setting that is more challenging than in others in terms of pollution or surface that don't allow for sewage, for seeping of water. But as I said, unfortunately, I think we need to wrap up, and I would like to hand then the floor to Surush. And thank you very much to all the speakers and the participants for their questions.
Well, thank you, Lucia and Ariel, for moderating the panel, and thank you to our panel members and speakers, Dr. Foster, Hirata, and Kosar. Fantastic, talks hitting different aspects, successes, and unfortunately the unpleasant situations that are emerging in many areas. Let's hope for better days. I always believe in cup half full, so hopefully the knowledge level will build up before some of these countries are badly affected. I just also wanted to thank Christina for organizing this and coming up with the idea originally. This is the third of our current year's forum under the Rosenberg. For the coming year, given the uncertainties, unfortunately, still surrounding the COVID and its various derivatives, we decided to continue the coming year with 3 more webinars, and the board is discussing topics, and we will hopefully be able to get back to the normal life and have our meeting in person, maybe in 2023. With that, again, thank you, and I wish you the best. And I also would like to acknowledge the founding chair of the Rosenberg Forum, Dr. Henry Wachs, who is always interested and participates. And thank you, Henry. With that, thank you again. We close it. Sherry, thank you.